I had some questions on standard deviation and z-score, so I wanted to clarify that and look at one of the problems from the homework. So I'm going to be looking at chapter 8, number 5 today. So first of all, just as a review, our standard deviation basically just tells us how spread out or how varied our data is. So a small standard deviation means our data is pretty clustered together, probably pretty close to our mean. A large standard deviation tells us our data is extremely is more spread out, meaning that some of the points are going to be quite a distance from our mean in comparison. So the best way to look at this is to draw a picture, and I drew my normal curve here. And if you remember, right down our center is the mean of our data. So for number 5, it tells us that the mean of our test scores is 50. That divides our data in half, or approximately half. If the data is perfectly normal, 50 would be our complete center. The first part says that we have a standard deviation of 5. So if I have a standard deviation of 5, and I'm going to go 1, 2, 3. Remember, most of our data lies within 3 standard deviations of our mean, and then we have very little bit outside on our tails. So a standard deviation of 5 means if I go out 1 standard deviation, I would add 5 onto my mean, because my standard deviation is 5. If I go out 2 standard deviations, I'm going to add 2 of those onto 50. So I'm going to add 5 plus another 5. And then if I go out 3, I'm going to add another 5 on. So each of these points represents another standard deviation away from our mean. So since our standard deviation is 5 in the first part of our example, excuse me, there we go. Since our 5 is our standard deviation, we just add that to the right. On the other side, since we're going to the left, 1 standard deviation to the left of our mean means we subtract 5, which is 45. And we keep doing that, so we subtract 5 each time because that's our standard deviation. So I've got 40, and then I've got 35. Okay, that's how we represent standard deviation. Notice our scores, for the majority of our scores range between 35 and 65. If we had, if we're looking at the empirical rule, that would represent 99.7% of our data because we're within 3 standard deviations of our mean. Does that ask much about that? Oh, and then the z-score. The z-score is actually each of these values right there. The +1 represents a z-score of 1. So a z-score of 1 is just 1 standard deviation from the mean, which is the 55. A z-score of 2 is our 60, meaning that we are 2 standard deviations away from the mean. And our +3 is our z equals 3, meaning we're 3 standard deviations from the mean. So the z-score just tells us how far from our mean we are, or basically the number of standard deviations we are from our mean. Our standard deviations help tell us how spread out or close together our data is. So the second part of our problem, and I'm going to try to do this so we can kind of see that top one as well, talks about having a standard deviation of 2.5. So our mean hasn't changed, and again, our data is going to be same type of a distribution, but this time we're only looking at 2.5, meaning our standard deviation is half as spread out. So we're going to, same thing, +1, +2, +3, and those represent our z-scores. So +1 would give us a standard deviation, excuse me. We'd add on our standard deviation of 2.5, which would put us at 52.5. And we add on another 2.5, which gives us 55, and then 57.5. Okay, so notice how at 3 standard deviations, if we do a comparison, when we only have a standard deviation of 2.5, our higher number in our range is only 57.5. When I have a standard deviation of 5, though, my higher number is a 65. So notice how larger standard deviation gives us a larger spread. Smaller standard deviation will give us a smaller spread. So continuing down here, we're going to subtract 2.5. So I'm going to get 47.5. Then I'm going to get 45. And then I'm going to get 42.5. Okay. Notice, again, our lower range is the same way. A smaller standard deviation gives us a smaller spread. larger standard deviation gives us a larger spread. Also, another way to look at that is our z-scores. When I have a z-score of 1, when I have a standard deviation of 5, I get a much larger number than when I have a z-score of 1 down here. I only get a 52.5. So that's what they wanted you to look at there, is they just want you to be able to visualize the difference in the standard deviations.